Good morning, class. We are looking at chapter 5, trigonometric functions. And here's section 5.2, unit circle. We covered angles and their measures, and now trigonometric functions, unit circle. The objectives are to find exact values of trig functions using a point on a unit circle, using the exact values of trig functions of quadrantal angles, finding the exact values of trig functions pi over 4 or 45 degrees, pi over 6 or 30, pi over 3 or 60 degrees. And exact values of their integer multiples. Use a calculator to approximate the value of a trig function. Use a circle of radius r to evaluate trig functions. So reminding you of what we have discussed, vertex, line, ray. So you have a line here. And you put two half lines together at point V. The point V is called the ray. The point V is called the vertex, and half line is called the ray. You have the vertex, the initial side, the terminal side going counterclockwise. That's a positive angle. Clockwise, negative angle. Standard position, the initial side is along the x-axis, positive x-axis. So this is in, theta is in standard position and theta is positive. In this case, theta is in standard position, but it's negative. A quadrantal angle is the one that the terminal side is along the x or y axis, positive or negative. Here's an example of that. This is also a quadrantal angle, and this angle is 90 degrees. It's 1/4 of a revolution. A complete revolution, 360 degrees, or 2 pi radians. This is 1/4 of it, pi over 2, or 90 degrees. So the terminal side is along the positive side of the y-axis. If the initial side is along the positive side of the x-axis and the terminal side along the negative side, this is a straight angle, half of revolution, 180 degrees, or pi radians. A complete revolution, 360 degrees, or 2 pi radians. The terminal and initial side end up being along the positive side of the x-axis. The relationship between degrees and radians is that pi radians is 180 degrees. So d over 180 equals r over pi. So if you want to go from one format to the next, if you have the degrees, put it here, find the missing r, radians. If you have in radians, put it here, cross product, find the missing d. One counterclockwise revolution is 360 degrees. 1 degree is 60 minutes. 1 minute is 60 seconds. Arc length. S equals r theta. Area of a sector, this portion of the circle, half of r squared theta. Angular speed, omega, the angle covered over the time it covers, so theta over t, 2 pi times RPM revolutions per minute. Could be RPS, revolutions per second. Linear speed, V, is S over T. In other words, if you look at this one, distance covered, S over T, that would be V. Angle covered, theta over T would be omega. Omega is the angular speed and V is the linear speed, which has the relationship of V equals R omega. That would be the relationship between the two. (5.2) trig functions, the unit circle. Circle of radius r centered at 0, 0 has the equation x squared plus y squared equals r squared. When r is 1, x squared plus y squared equals 1 is called the unit circle. So unit circle crosses the two axes at 1, 0, 0, 1, negative 1, 0, 0, negative 1. S equals t units. Let t be a real number and let p, having coordinates x and comma y, be the point on the unit circle that corresponds to t. Then here's the information we should understand. Again, we said x squared plus y squared equals 1. P has coordinates x and comma y. Sine t is represented by y. Cosine t is represented by x. Again, reminding you that this one centered at 0 has the equation x squared plus y squared equals r squared. If it's centered at h and k, x minus h quantity squared plus y minus k quantity squared equals r squared. So let t be a real number and let p with coordinates x and y be the point on the unit circle that corresponds to t. Then what happens? This point has coordinates x and y. The sine function associates with t the y coordinate of the p and is denoted by y equals sine t. The cosine function associates with t the x coordinate of the p and it's x equals cosine t. If x is not equal to 0, the tangent function associates with t the ratio of the y coordinate to the x coordinate of p, and it's denoted by tangent t is y over x. Those are definitions. So, in short, you have a pair x comma y on a unit circle. X represents cosine t, and here's t, the angle t or the arc t, st. Y is sine t. Tangent, as you may recall, is the ratio of sine over cosine, therefore is y over x. The rest of the trigonometric functions follow. Tangent is y over x. Now cotangent is the reciprocal of tangent, x over y. Cosecant is the reciprocal of sine, 1 over y. And secant is the reciprocal of cosine, 1 over x. Needless to say, in all of these cases, you're dealing with a fraction, the denominators cannot be zero in any of those cases. So that's the synopsis of what was discussed. Find the exact value of all three functions if P has coordinates -1/2 and square root of 3/2 is a point on a unit circle. By the way, in order to prove a point belongs to a unit circle, square this one, add them up, and it must become 1. This is 1/4, this is 3/4, they add up to 4/4. So we put that on a unit circle with coordinates -1/2 and square root of 3/2. So the x is -1/2, the y is square root of 3/2. So this is the x coordinate, this is the y coordinate. And as you know, x represents cosine, y represents sine. So sine t is y square root of 3/2. Cosine is x or -1/2. The rest of them are easy. Tangent is y over x. Negative square root of 3, because square root of 3/2 over -1/2 is negative square root of 3. The rest of them are reciprocals. Cosecant is 2/square root of 3. Secant is 2/-1, meaning -2. Cotangent is 1/square root of -3. And when you rationalize it, as an example, class, this one is 2/square root of 3. So if you multiply it by square root of 3/3, you get this one. This one is -1/square root of 3. If you multiply that by square root of 3/3, rationalize it, and you get minus square root of 3/3. Find the exact values of the trig functions of quadrantal angles. Reminding everybody, quadrantal angles are angles that the terminal side is along the x or y axis, positive or negative. For example, theta is 0 degrees. And you know this point has coordinates 1, 0. X is cosine, y is sine. So sine of 0 is 0. Cosine of 0 equals 1. Remember, x, y represented by cosine and sine. So here's cosine, here's sine. Sine of 0 is 0. Cosine of 0 degrees is 1. The rest of them follow. What is tan of 0? Tan of 0 is 0/1. Tan of 0 is 0. Let's discuss the rest of it. So cotangent becomes undefined. Cosecant is 1/sine, becomes undefined. Secant is 1/cosine, 1/1, becomes 1. Pi over 2. In the case of pi over 2, the terminal side is along the positive side of the y-axis. Remember, this is 0, this is pi over 2. Or 90 degrees, this is pi, or 180 degrees, this is 3 pi over 2, or 270 degrees. And so this has coordinates 0, 1. In this case, cosine is 0, sine is 1. So sine of pi over 2 is 1, cosine of pi over 2 is 0. Therefore, if I want to find the tangent, which is sine over cosine, becomes undefined. UD short for undefined. But cotangent is cosine over sine, 0 over 1, and it's 0. Cosecant is 1 over sine, and it's 1. Secant is again undefined because this is 1 over cosine. Let's go with pi. What happens here? It's very straightforward, everybody. This has coordinates negative 1, 0, which means x is negative 1, cosine is negative 1, y is 0, sine is 0. Sine of pi is 0, cosine of pi is negative. So that makes tangent 0, because tangent is sine over cosine. And if tangent is 0, cotangent is undefined. Cosecant is 1 over sine, undefined. Secant is 1 over cosine. 1 over negative 1 makes it negative 1. Three pi over 2. This one has coordinates 0, negative 1. X is 0, so cosine is 0. Y is negative 1. Sine is negative 1. Sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0. And so tangent is sine over cosine. It makes tangent undefined. Cotangent makes it 0 over negative 1 or 0. Cosecant is 1 over sine, so it's 1 over negative 1 is negative 1. Secant is 1 over cosine, 1 over 0 is undefined. So it's pretty straightforward how we arrive at those answers, everybody. So again, we are looking at various angles. So this theta covers this T. S equals R theta. S is T unit. Sometimes they call it SM, sometimes they call it T. So theta is T radians. Theta is T radians here. Counterclockwise positive, clockwise negative. Definition: if theta equals t radians, the 6 trigonometric functions of the angle theta are defined as follows. Sine theta is sine of t, cosine theta is cosine t, tan theta is tan t, and the rest of them follow. So it's very straightforward, everybody. And these are common arcs. 0 power 2 pi 3 power 2. They are also quadrantal angles. 0 radian 0 degrees, power 2 radians 90 degrees, pi 180, 3 power 2 270. And these are the values we went over. Hopefully you don't have to just memorize it. Like, just remember what we did in the previous page and the unit circle, all of them you will know. And at the very least, if you know sine and cosine, you can figure out the rest easily because of the relationship they play with sine and cosine. Tangent is sine over cosine, and the rest of them are reciprocals. So first of all, reminding everybody x comma y as coordinates cosine t and sine t. Find the exact values of the trig functions that are multiples of quadrant angles. Well, clearly sine of 3 pi is 3 times pi. That makes it multiples of a quadrant angle pi. So let's do the graph. That means go a complete revolution and then add a pi, because 3 pi is 2 pi plus pi. So you go a complete revolution. 2 pi is a complete revolution, everybody. And then get back to pi. And that gives us -1, 0. Sine is y, therefore is 0. If they were asking for cosine, we would say a -1, but sine of 3 pi is the same as sine of pi, and it's equal to 0. Cosine of -270 degrees. So we are going to go in a negative direction, 270 degrees. So when you go in a negative direction, it puts you at this point with coordinates 0, 1. Cosine is 0, sine is 1. We want cosine. It's the x coordinate, and therefore 0. Very straightforward, everybody. Find the exact values of the trig functions of pi over 4 or 45 degrees. And let's see what we do. Again, bear in mind x comma y. X is represented by cosine and y by sine. So note P, this 45 degrees, lies on the line y equals x, because this angle is 45 degrees. This angle, remember, from here to here is 90 degrees. So both of them must be 45 degrees, right? Each one is 45 degrees. And that gives us the line y equals x. That's important to notice that. So we have the coordinates x comma y, and because it's on the line y equals x, the coordinates are the same. You can say x comma x, or you can say y comma y. We know x squared plus y squared is equals 1. So the y coordinate is also x. So we have x squared plus x squared equals 1. And by the way, both of them are positive because we're in the first quadrant. This is quadrant 1. By the way, that's how we know about trigonometric functions, also based on the quadrant, based on x and y. So having said that, means 2x squared is 1. X squared is 1/2. X is plus minus square root of 1/2, but we keep the positive one. And we rationalize it to square root of 2 over 2. We know x is equal to y. So we have the same answer for both x equals y equals square root of 2 over 2. And the pair, therefore, must end up having coordinates square root of 2 over 2, comma, square root of 2 over 2. Which means sine and cosine of power 4, both of them are the same, square root of 2 over 2. So this one has coordinates square root of 2 over 2. This one has coordinates square root of 2 over 2. And so this represents cosine, this represents sine, and we have those. What about tangent? Tangent is sine over cosine. What is the ratio of two numbers that are identical is 1. So if tangent becomes 1, so is cotangent. And now what about cosecant or secant? Reciprocal of this, 2. For this one, the reciprocal would be 2 over square root of 2. And 2 over square root of 2, I hope you know it's square root of 2. So secant and cosecant, both of them are square root of 2. And again, I can't emphasize this enough. As long as we know that, we can get to the rest. For power 4, we really should know sine and cosine are square root of 2 over 2, and power and tangent is 1. Those are handy. We come across them often. So what is sine of 45 times tan of 45? And we are supposed to know this by heart. Common arcs, you have to memorize it. This is square root of 2 over 2. This is 1. Their product is square root of 2 over 2. Secant. If you don't know the secant, you know cosine, just write the reciprocal of that. But if you know it, it's square root of 2, plug in. But it's up to you. So square root of 2, of course, cotangent is the same as tangent, and there you have it. But like I said, I can't emphasize this enough. This one, you can say 1 over cosine of power 4, or 1 over square root of 2 over 2, which gives you that number. Sine of 45, square root of 2 over 2. Cosine of 180, remember, 180 or pi, x comma y, the x coordinate is negative 1. So their product is negative square root of 2 over 2. Tan of power 4 is positive 1 minus sine of 3 power 2. Remember, sine of power 2 is positive 1, 3 power 2 is negative 1. So minus negative 1. So negative times negative makes it positive. They add up to 2. Secant of power 4 quantity squared. Well, secant of power 4 is square root of 2. Squared, you get positive 2. cosecant of pi over 2, and even if you haven't memorized, just remember is 1 over sine of pi over 2. Sine of pi over 2 is 1, 1 over that is 1. So square root of 2 squared plus 1, which makes it 3. Even this one, if you don't know, 1 over cosine of pi over 4, okay? We can go that route. All right, let's look at some definitions we have seen in algebra geometry. A triangle is a specific type of polygon having only 3 sides and 3 angles. The angle sum property of triangle says the sum of all interior angles of a triangle will always add up to 180 degrees. Types of triangles with respect to the length of the sides. Scaling triangle, all sides and angles have different measures. Isosceles triangle has 2 equal sides and 2 equal angles. Equilateral triangle, all sides and angle are equal 60 degrees because 180 divided by 360. So these are the 3 types. Types of triangles with respect to the angles. Right angle triangle, one of the 3 interior angles must be 90 degrees. Acute angle triangle, all the 3 interior angles are acute, that means less than 90 degrees. Obtuse angle triangle means one of the 3 interior angles is an obtuse angle, which means has a measure greater than 90 degrees. So 90 degree here, these 2 must be less than 90, okay? So those are acute. These all 3 are less than 90. This one of them is larger than 90, which makes the other one definitely acute, less than 90. Find the exact values of the trigonometric functions of pi over 6 equals 30 degrees and pi over 3 equals 60 degrees. Here's how we start. We start with the right triangle of hypotenuse 1. So on purpose, we choose this one to be 1. This is A, this is B. And we choose 30 and 60. They add up to 90 degrees. So right triangle. So one angle is 30 or pi over 6. Another one is 60 or pi over 3. That's on purpose. Make a second congruent triangle. Make an equal one in essence and put next to it. Just equal to that next to it. When we do that, what happens? This is 30, this is 30, this is 90, this is 90, and this is 60. So what you create, this is 1, this is 1, and this is 1. You create an equilateral. Each side is 1. The triangle here is equilateral, so all sides are 1, therefore 2 times A must be 1, A must be 1/2. Remember, this was C, this was B, this was A. And we know A squared plus B squared equals C squared, A squared plus B squared equals C squared based on Pythagorean theorem. And we know A is 1/2, so it's 1/4. B we don't know, and we know C is 1, so 1 squared is 1. So this is because 1/2 squared. And so we get 3/4, and the square root of that is square root of 3/4, which makes it the square root of 3/2. So we have all sides, everybody. So this side is 1/2. We had it, and now B is square root of 3/2. All right, so this is what we have shown, that if this is 30 degrees, this is 60 degrees, and this side is 1/2, this side is 1, this side is 1/2, this side is square root of 3/2. So let's put that into a unit circle. And so this side is 1/2, this side is square root of 3/2. That means x has coordinate 1/2, y has coordinate square root of 3/2. X represents cosine, y represents sine. So using that, sine of power 3 or sine of 60 is square root of 3/2. Therefore, cosine is 1/2. The rest of them are easy to find. You know what to do. Tangent is sine over cosine. Makes it square root of 3. Now, the rest of them are reciprocals. The rest of them are reciprocals. Cosecant is the reciprocal of that, 2 over square root of 3. And you can rationalize it. 2 square root of 3/3. Secant is the reciprocal of 1/2 is 2. Cotangent is the reciprocal of this, and we get square root of 3/3. So pretty straightforward, everybody. So we can easily find all of those. And we're going to move on. All right, so now what happens? We are going to work on power 6 or 30 degrees. Find the exact values of the trigonometry function power 6 or 30 degrees. If we put it on a unit circle, x comma y, now this time x is square root of 3/2. That means cosine of 30 degrees square root of 3/2. Y is 1/2. That means sine of 30 degrees or power 6 is 1/2. Okay, so pretty straightforward, everybody. Sine and cosine. Can't get any easier than that. So what happens to tangent? Sine over cosine. 1/2 over square root of 3/2. and that is 1 over square root of 3. We've shown in the previous page. So this is 1 over square root of 3. We rationalize it, we get square root of 3 over 3. The rest of them are reciprocals. So this one, cosecant of pi over 6 or 30 degrees is 2. Again, as long as you have these two, you can get the rest of them. You don't have to memorize in class. Okay, just in case. Secant is 1 over cosine. The reciprocal of this is 2 over square root of 3, and then rationalize, you get 2 square root of 3 over 3. And cotangent is the reciprocal of a tangent. 3 over square root of 3, I hope you recognize the square root of 3. If you want, you can multiply by square root of 3 over square root of 3, which becomes 3 square root of 3 over 3. Either way, it's easy to prove that, okay? A rain gutter is to be constructed from a metal sheet of width 12 inches. So this is 12 inches. By bending up 1/3 of the sheet on each side through an angle of theta. So we're going to bend it here. We're going to bend it here, and it will look like this. Which means this is 4, this is 4, this is 4. Each one is 4 inches. 4 inches long. Sheet on each side through an angle of theta. So this is the angle of theta, and of course these two lines are parallel, so this crosses it. These two angles are equal. These two angles are equal, by the way. Prove that the area A of the opening is given as A of theta equals 16 sine theta times cosine theta plus 1. This is a trapezoid. The area of a trapezoid area is 1/2 the height times B1 plus B2. Again, I hope you recognize this as a trapezoid. Okay, everybody. So all we have to do, figure out the H, and then B1 and B2. B1 is 4. B2 is 4 plus this much and this much. Each one of those is 4 cosine theta, and the height is 4 sine theta. So if you look at this, let's see. This is a triangle, okay. This is a 90-degree. 90-degree angle. So H is 4 sine theta. This is the height, everybody. So let's make the triangle larger here. This is the height. This is 4 inches. And this is theta. So is this one. So sine theta is the opposite over the hypotenuse, which means h over 4 inches. So h becomes 4 times sine theta. Cosine theta equals the adjacent. This is the adjacent. Let's call this distance b. B over the hypotenuse 4. And b is 4 cosine theta. So this distance is 4 cosine theta. This distance is 4 cosine theta. So is this one. So now let's clean up my work. So the height is 4 sine theta. B1, the smaller base, is 4. B2, the larger base, from let's call this point A. Let's call this point B. And so B2 is AB. So it's this large base. This portion of it is 4 cosine theta. This portion of it is 4 cosine theta. This portion is like this one, 4. So 4 plus 4 cosine theta plus 4 cosine theta. Let's put it into this. Half of the height, which is 4 sine theta, times this. Half and 4 is 2 sine theta. 4 and 4, 8. 4 and 4, 8. So 8 and 8 cosine theta. We can take the 8 out. From here. Eight times 2 is 16. And whether you write 16 sine theta times 1 plus cosine theta or cosine theta plus 1 makes no difference. We proved it. Now plug in 30, 45, 60. We're not going to spend too much time on it. Just plug in 30. 16 sine 30 cosine of 30 plus 1. You know sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. This is 8. Multiply by this one, we get 4 square root of 3. Multiply by this one, we get 8. This is an exact answer. Put it into a calculator. And don't forget the units of inch for each side. So the area would be inch squared. That's important to understand how to write units. So this is an approximation. This is exact. Let me just write this. This is important. And you should always write the exact and then if need be an approximation. This is an exact answer, exact area. When theta is 30 degrees. Now we're going to plug in 45 and 60 pretty fast. We need to move on. When we plug in 45, we get 16 sine of 45 cosine of 45 plus 1. As you know, sine of 45 and cosine of 45, both of them are square root of 2 over 2. So first and foremost, this becomes 8. This goes away. So 8 square root of 2. When you multiply these two, square root of 2 times square root of 2 is 2. 2 times 8, 16. Divided by 2 is 8. And if you multiply it by 1, it's 8 square root of 2. Again, exact answer, everybody. Exact. Put it into a calculator. 19.31 inch squared. We do the same thing with 60 degrees. And we should know that sine of 60 is square root of 3 over 2, and cosine is 1/2. Class, this is going to go away. This becomes 8, and this is 3/2. So 8 times 3, 24, divided by 2 is 12 times square root of 3. Again, exact answer. Roughly 20.78 inch squared. All right, so we have other common arcs such as 30 degrees, 45 degrees, and 60 degrees. We discussed quadrantal angles 0, 90, 180, and 270 degrees. Now we are adding 30, 45, and 60 degrees. We should remember it. So if we have integer multiples, we should figure them out. There are different ways, but one way is to look at them is this way. For example, we know in the case of pi over 4, this has coordinate square root of 2 over 2 and square root of 2 over 2. So if we go across, then in the third quadrant, we have the same values but negative. If we drop a perpendicular to the y-axis and continue until we hit the unit circle, x on the left side is negative, but the y is positive. If we drop a perpendicular to the x-axis and we continue, the x remains positive, the y becomes negative. Therefore, we should recognize that this one, which is multiples of pi over 4, in this case 3 pi over 4, cosine is negative, sine is positive. And by the way, remember, cosine is x, so cosine is positive. In the first quadrant, everything is positive. So because cosine corresponds to x, it's negative in the second and third quadrant. Sine corresponds to y, it's positive in the first and fourth quadrant. Remember that, because we're going to need that later on. So always think of x comma y. X comma y, it will help you figure it out. You can do the same thing with other angles such as pi over 6. Just connect it to the origin, continue, both of them become negative, drop a perpendicular to the y or the x-axis, so on and so forth. Just remember, again, can't emphasize this enough, the x coordinate represents the cosine, the y coordinate represents the sine. You know where x is positive, where y is positive, and also where they are negative. So you should be able to come up with those easy. And of course, remember pi over 4 is the same as 45 degrees. So therefore, 3 pi over 4 is 3 times that, 135 degrees. So know both degrees and radians. We want to find the exact values of multiples of 30 and 60. 30 is pi over 6, 60 is pi over 3, and cosine of 150. And I'm reminding you of those. And 150, cosine of 150 is the same as 5 times 30 is the same as 5 pi over 6. And again, remember over here, we know what happens with the x and y. So cosine is x, square root of 3 over 2. But in this quadrant, we know x becomes negative, therefore cosine becomes the same value but negative. Sine of 30 degrees would be here. Sine of minus 30 degrees is the sine of minus pi over 6. It takes you to the fourth quadrant. Sine is associated with the y coordinate and therefore negative 1/2. Tangent of 4 pi over 3. So it's associated with pi over 3. 4 pi over 3 puts us in the third quadrant. In the third quadrant, both sine and cosine are negative. Because both are negative, the ratio is positive, and that's the key. So you can put the ratios, sine, which is the y coordinate, over the y, which is the x coordinate, and it becomes positive square root of 3. Sine of 7 pi over 4. 7 pi over 4 puts us in the fourth quadrant. In the fourth quadrant, sine associated with the y is negative. And therefore, it's minus square root of 2 over 2. Minus square root of 2 over 2. That's the answer. Minus square root of 2 over 2. Very straightforward, understanding where to look for what and paying attention to the simple case that x is associated with cosine, y is associated with sine. So sine of 7 pi over 4 minus square root of 2 over 2. Seven pi over 4 is plus square root of 2 over 2. My apologies, because it's in actually the fourth quadrant. It's the same as pi over 4 and minus. Yeah, I put minus. That's right. I'm confusing everybody. My apologies. Because sine is the second one. All right. Use a calculator to approximate the value of a trigonometric function. Your calculator has buttons for sine, cosine, and tangent class. Okay, you know that. To find the values of the remaining three trigonometric functions, we use the reciprocals. So for example, when we are dealing with cases that are not common arcs, for example, cosine of 48 degrees, we put it into a calculator. Cosine of 48 is 0.66913, and it continues indefinitely. You do the rounding accordingly. If they don't ask you to round, you come up with the exact answer. You carry out as many decimals as you can. For cosecant, we don't have a button for it. We write it 1 over sine, and we get 2.79 and continue. It's important to know in these two cases must be in, the mode must be in degrees. However, this one must be in radians. And it gives you the answer 0.267, and it continues. Now, remember to change the mode to radians. The way you do it, when you click on the mode, over here you have a choice of keeping it on radian or move it to degrees and enter. In this case, we have degrees. In this case, we have radians. As an example, tan of power 12 is 0.272679, and it continues indefinitely. So again, it's important to have it in the proper mode, radian versus degrees, as you use a calculator. Use a circle of radius r to evaluate the trigonometric functions. Remember, x squared plus y squared equals 1 when the center is located at 0, 0, and the radius is 1. But if it's not, x squared plus y squared equals r squared, in which case x squared plus y squared equals r squared. And the formulas, remember, when it's 1, sine is y, cosine is x. When it's not, now sine is y over r and cosine is x over r. Just pay attention to these two. The rest of them follow, meaning tangent is sine over cosine, it remains as y over x. Now cosecant, the rest of them are the reciprocals. Cosecant, if you want to go with that, is r over y instead of 1 over y. Secant is r over x. Cotangent is x over y. Needless to say, none of the denominators can be 0. And so, if x squared plus y squared equals r squared, and P has coordinates x comma y, let's say a comma b, not to mix it up with, normally we used x, y when the radius was 1. So sine is y over r, or b over r, cosine is x over r, or a over r, and the rest of them follow. I hope everybody is okay with that. Remember, the difference is now we are not using the unit circle. We are using x squared plus y squared equals r squared. So find the exact values of the 6 trigonometric functions of a positive angle theta if this pair x comma y is 4 comma -3 is a point on its terminal side. Four to the right, 3 down puts us here. So the very first thing is to calculate the radius becomes 5 because 4 squared plus -3 squared. So A and B have coordinates 4 comma -3, and you square each one. You get 16 and 9, 25, and their square root is 5. All right. So what is sine? Y over R or B over R? B over R minus 3 over 5. Cosine theta A over R, 4 over 5. And tan theta is B over A, -3/4. So with sine goes cosecant minus 5, there's the reciprocal of that. With cosine goes secant 5 over 4. With tangent goes cotangent. The reciprocal is -4/3. Or you can write R over B, R over A over B. Just the reciprocal is good enough. So it's pretty straightforward, everybody. We're going to find the exact value of the value of each expression. Those are multiples of 45 degrees. Cosine of 135, 3 pi over 4, 225 minus 5 pi over 4, 9 pi over 4. So for 135 degrees or 3 pi over 4, we have this pair, everybody. Cosine is associated with x, so it makes a negative square root of 2 over 2. 3 pi over 4, the same thing as 135 degrees. And tangent is the ratio of those two, becomes -1. Sine over cosine. $225 180 plus 45, it's in the third quadrant, or 5 pi over 4 minus square root of 2 over 2, both of them. Okay, so what is sine of 225 5 is minus square root of 2 over 2 because it's the y coordinate. Negative 5 power 4. That means start from here and go this way. And if it makes it difficult to understand, class, add 2 pi just for the sake of argument. So you see, if you said and 2 pi or 8 power 4 makes it 3 power 4. So it's the same as, so going this way in a negative direction, 5 power 4 in the negative direction is the same as going in the positive direction, 3 power 4. And it gives us this pair. And so what do we want? Cosine is associated with the x minus square root of 2 over 2. 9 pi over 4 is 8 pi over 4. That means 2 pi plus pi over 4. That means a complete revolution. So we go a complete revolution in the positive direction and then pi over 4. So it puts us right where pi over 4 is. And sine or cosine makes no difference. Both of them are the same. Square root of 2 over 2. That's the final answer. Now, the other method is called the reference angle or arc. The notations depending on the text. Theta hat, theta sub r, theta prime. I've seen theta bar as well. In the first quadrant, theta, the reference angle theta hat or theta sub r is the same as theta. In the second quadrant, pi minus theta. In other words, multiples of pi over 4 in any quadrant have the same value. The only thing is you have to figure out a positive or negative, okay? And so as far as the theta is in order to find the reference arc to see what it covers, pi minus theta in the second quadrant, theta minus pi, because it's larger than pi in the third quadrant. In the fourth quadrant, 2 pi minus theta. This is how you find the reference arc and you calculate it accordingly. So for the sake of argument, 225 degrees is in the third quadrant, just as an example. So theta is 225, okay, minus pi. And by the way, pi or 180 degrees, right? That's 45 degrees. So that means this is the same as sine of 45 degrees, but positive or negative, you have to figure out based on the quadrant. Because in the third quadrant, sine is negative, so the same value as sine of 45 degrees, which is square root of 2 over 2, in the third quadrant, you make it negative. That's how you use reference arcs or reference angles.